Okay guys, just to finish the notes I had intended to finish in class today, let's do one more practice with derivatives. So we have, oh, bell rang, f of x equals 1 over the square root of x. So we want to find the derivative. First we should make this 1 over x to the 1/2, which is x to the negative 1/2. And then when we find the derivative, remember we multiply this by the coefficient, but that just happens to be negative 1/2. And then x, and the power is negative 1/2 minus 1. So that's negative 1/2 x to the negative 3 over 2, which we typically leave just like that. But if you want, you can make it 1 over 2x to the 3/2, and that's negative. So that's just one more example of finding the general equation for the derivative. Now, if you remember that the derivative represents the slope of the tangent line. So the derivative represents the slope of the tangent line at any point on the curve. And that was just when you plugged in, if they gave you like x sub 0 equals 4, you just plugged it in and you found a number. That number you found is the slope. So putting it all together, the derivative is equal to the slope of the tangent line, which is equal to the first definition that we had, the limit as h approaches 0 of f of x plus h minus f of x over h. So that is what we learned. And then you can also write an equation for the tangent line. And you just use the point slope form. So that's y minus y1 equals m times x minus x1. And how does that relate to what we've been doing? Well, we would take y minus f of x sub 0. That's just the y value at the point of tangency. And that equals f prime of x sub 0. Remember, that's just the slope. And then times x minus x sub 0, which is the point of tangency. And I'm running out of room. Okay, so let's try an example of that. If I have y equals x squared, and I want you to find the equation of the tangent line at x sub 0 equals 4. Well, first you'd find the derivative, which is the slope. So the slope is the derivative, which we do our easy way now, and it's just 2x. And then our slope, and then our slope at our point of tangency, so that's plugging in 4 into the derivative, is 2 times 4, right? Now, as we go to start writing our equation, we've got y minus y1 equals, why did I put y1? Because we actually don't know it yet, equals m. So m is, I didn't finish this, did I? M is 8 times x minus x sub 0 is 4. So how do I find this y value? Well, if it's the point of tangency, it has to touch the graph at 4 comma something. The point of tangency would also be on the graph. So if you plug in and find f of 4, you get 4 squared, which is 16. So we have overall y minus 16 equals 8 times x minus 4. And for tangent lines, you can always leave it in point slope form. And let's try another easy one. Let's do y equals x squared minus 2. So we know that the derivative is just 2x. And then we know, oops, forgot to tell you the point of tangency. The point of tangency is x equals 2. So we take the derivative evaluated at 2. So 2 times 2 is 4. And remember, this is the slope right here, right? So what do we need? We need an x0, y0, and m. The only thing we don't have is y sub 0. And again, remember, at the point of tangency, it touches the graph. So if I just find f of 2, that's my y sub 0. So f of 2, I don't know why I wrote that again. So f of 2 equals 2 squared minus 2, which happens to be 2. So it goes through the point 2, 2, and we have a slope of 4. So y minus 2 equals m, which is 4. Why do I keep messing up? Whoops. So equals 4 times x minus 2, and we are done. I also want you to see the graph of what this looks like. So I'm going to go ahead and graph the parabola and the tangent line, because that's part of your homework. So if I graph, we should all know what that is. It's a parabola that is shifted down 2. So the vertex is at 0, negative 2. If we plugged in 1, we'd get negative 1. If we plugged in 2, we would get 2. You should know how to graph this. This should not be any surprise here. So there's my parabola, right? My point of tangency is at 2, 2. And then we do the line, right? We're going to do our tangent line like right here. But let's see exactly what it looks like. So I'm going to go down here and solve for y. Y minus 2 equals 4x minus 8. Y equals 4x minus 6. So if I graphed that, 1, 2, 3, 4, 5, 6, negative 6, and I went up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1. This is my tangent line. Wow, that is so not straight. But, yeah, there's no undo. Oh, here we go. No, it's not undoing. Forget it. That's a yucky line, but it's all good. It should look kind of like that and only touch the graph right there. And one last thing, let's remember that the slope equals the rate of change. So you're finding, I know this is sloppy, it's hard with a stylus. So the slope is the rate of change. So you're finding the rate of change at any given point, on a curve. All right? So let's just talk about that real quick, what that means. Oh, should I leave it there so you can write it? A little bit more time to write it. I'll pause so you can write it because I got to move it up. I'm going to move it up just a little bit. And then the key here is for objects in motion, we need to know speed and direction, which is velocity. And so f prime of x, the derivative, tells us the velocity of whatever is moving along that curve. So hopefully that makes sense, and I'll answer questions tomorrow.